Okay, now that we know how to do prime factorizations, we can use those prime factorizations in one way. Remember, we're going to use them in lots of ways, but one way is to find the greatest common divisor and the least common multiple. So after finding our after finding our prime factorizations, to find the greatest common divisor, we're going to select the prime numbers that factorizations have in common and use the smallest exponent of each. To find the least common multiple, we select every prime number that appears and use the largest exponent. So sometimes it's confusing to students because we have the word here greatest common divisor, and we're looking for the smallest exponent. And over here the word is least common multiple, and we want the largest. So instead of thinking about the words greatest and least, try to help us remember that largest starts with a L. So that's the one I want the largest for, is the one that has the L in it, the largest number of exponents. So don't think about the title of what we're doing. Think about the action. Oh, this one has an L in it. I'm going to find the largest exponents. Okay, so let's find the greatest common divisor and the least common multiple for a couple of pairs of numbers. Okay. So first thing I'm going to do is I'm going to find the prime factorization of each number. So 40 is maybe what? 5 times 8. Oh, I've already got a prime number here. 8 is 2 times 4. There's another prime. And 4 is 2 times 2. Okay. So that means all my primes, there are 3 2s and 1 5. 48, maybe 6 times 8. Right? 12 times 4, whatever you think of. 6 is 2 times 3, and that's the only way we can write that. So 8 is 2 times 4. I got 3 primes out of that step. But I'm still continuing with the 4 because I can write it 2 times 2. All right, so my prime factorization, I just have 2s and 3s. 1, 2, 3, 4 2s and 1 3. Okay, now to find the greatest common divisor, okay, I'm going to take everything they have in common, okay, so they have the 2 in common, and the smallest exponent, that's my greatest common divisor. To find the least common multiple, I'm going to take everything. They have 2s, 3s, and 5s, right? So once again, whenever I'm thinking smallest here, I'm also thinking a smallest number of divisors. Here with the largest, I'm taking them all the divisors and the largest exponent. So a 4, and of course the largest exponent on this one, I don't have to write it, I'm just doing that for emphasis, right? Okay, so my greatest common divisor is 8. We could multiply these out if we want to, or I can leave it in exponential form. Let's do it for 72 and 100. Okay, so the first thing I've got to do is find the prime factorization for each one. So 72, what do you think of? 9 times 8? 9 is 3 times 3, and 8 is 2 times 4. Okay, well, these are ending right there, but 4 is continuing. 2 times 2. All right, So we've got 3 2s and 2 3s. Now let's do 100. 10 times 10, you think? 50 times 2, whatever you want to do. 10 is 2 times 5, and 10 is 2 times 5. So this all ends right here. And we have 2 2s and 2 5s. Okay, greatest common divisor. Since it doesn't have an L, it's the smallest they have in common, which is 2's, and the smallest exponent on that. Okay, the least common multiple has that L, so I want the largest number of factors I can get. In other words, all of them that they have in common, and I want the largest exponents. If I have to choose between a 3 and a 2, I'm going to choose a 3. Right? This is the only exponent on the 2 and the 5. So greatest common divisor is 4. Least common multiple is 72 times 25. Right? Or written out like this. Greatest common divisor, least common multiple. Let me know if you have questions.